Hello learners, welcome to EduRev. Today we are going to decode the chapter rational numbers. Now before we actually study that what rational numbers are, let me ask you a question. Have you ever shared pizza with your friends? And if you have, then in what fraction did you share it? Did you take the bigger piece or the smaller one? Now, I think we all have done this. We all have shared pizzas with our friends. But can we relate this fraction, this sharing of part of pizza with mathematics? I'm sure we can do this. Now, a branch of mathematics that I can relate to about all of this is rational numbers. Rational numbers are used in everyday life purposes for calculations of your loans, your taxes, your interest, and even for sharing of your pizza. So, what are we waiting for? Let's decode this chapter. Now, in mathematics, a rational number is a number that can be expressed as what? Quotient or fraction, that is p by q, of two integers, that is p and q are integers where q cannot be equal to 0. So whenever we encounter this type of situation, then that number is referred to as your rational numbers. Therefore, when you split the pizza into 6 pieces and pick 2 out of them, and then you will be having 2 by 6th of a pizza, or I can say 1/3 of a pizza. And now this 1 by 3 is nothing but it's your rational number, because 1 by 3 is of the form p by q, where q is not equal to 0. I hope you people have understood till here. Now, let's understand how rational numbers are related to all of this. We can see that whole numbers are a part of integers, obviously, because whole numbers are nothing but 0, 1, 2, 3, and so on till infinity. Whereas integers include negative of these numbers as well, that is negative of 1, negative of 2, negative of 3, and all that, right? So integers plus your whole numbers and your fractions will give you what? Your rational numbers. Whereas irrational number is a separate column, so we do not have to worry about them right now. We just need to understand that what these rational numbers are. So let's study about rational numbers. In this diagram, you can easily see that how whole numbers are a part of integers and integers are a part of rational numbers, as I talked that in your rational numbers, you have integers plus you have these fractions, all right, these decimal parts. So all these comprise and form what? Rational numbers. Now there is a bigger set of numbers, that is your real numbers, which are formed with addition of your rational numbers, that is all the rational numbers plus your irrational numbers will form what? Your real numbers. So you do not have to worry about other numbers. Today we are only going to refer and study that what exactly are rational numbers. So for that purposes, let's first of all study that what are whole numbers and natural numbers. Now, whenever I talk about whole numbers and natural numbers, there is this one thing common in both of them. That is, all the numbers from 1, 2, 3 up till infinity will come in both the sets, in your whole numbers as well as in your natural numbers as well. But what is different? The only thing that is different is 0. So 0 is included in your whole numbers, but it's not included in your natural numbers. That is, natural numbers is a set of numbers starting from 1, that is 1, 2, 3 up till infinity. Whereas whole numbers is a set starting from 0, 1, 2, 3 up till infinity. So we can say what? We can say that natural numbers plus 0 forms what? Your whole numbers. Correct? Now natural numbers is denoted by your capital N and whole numbers are denoted by your capital W. I hope this is clear. Next, yes, see this diagram. This is explaining exactly what I've told you right now, that natural numbers are going to start from 1, that is 1, 2, 3 and so on, and whole numbers is going to be nothing but natural numbers plus one number, that is your 0. So this is what your 0. So 0 plus natural numbers will give me what? Whole numbers. Easy, right? Now let's study that what are integers. Now integers are what? They are whole numbers and they're negative. This is also something that I've explained to you in the previous slide, that when I talk about whole numbers, I will write all these numbers, right? And integers will be negative of these numbers as well. Now keep in mind that 0 is neither positive nor negative, so we do not associate any sign with 0. We only associate sign with other numbers, that is 1, 2, 3, 4. That's why we also write the negative of these numbers, that is -1, -2, -3, etc. So all the negative numbers plus your 0 plus all the positive numbers will formulate what? Your integers. Correct? So integers will be what? Integers will be basically whole numbers plus their negatives. So this is going to be what? Your integers. An integer is written how? With your capital I or your capital Z. So it's your choice whether you want to associate Z with them or you want to write I for integers. I hope you have understood this. Yes, now lastly, let's again come back to rational numbers, and once again, let's see what is, the definition of rational numbers. So what is rational number? It's any number of the form P by Q where Q is not equal to 0, and you can denote rational numbers with your capital Q. For example, negative of 5 by 7 is going to be a rational number. Why? Because negative of 5 and 7, both of them are integers and they are of the form what? P by Q. That is minus 5 by 7 is of the form P by Q, where Q, which in this case is 7, is not equal to 0. So therefore, negative of 5 by 7 is going to be your rational number. Even 2 is going to be your rational number. How? Let me explain you. 2 can be written as what? 2 by 1, right? So that means this is of the form what? P by Q, where Q is what? Q here is 1 and this is not equal to 0. So because the number 2 satisfy all these conditions, that is, it is of the form P by Q, where Q is not equal to 0 and P and Q, both of them are integers, therefore we can say that the number 2 is what? Nothing but a rational number. I hope you have understood this. So now let's move forward. All right, let's solve this question. Let's solve this question now. So what does this question ask? This question basically asks that we need to pick rational numbers from the following numbers. So there are a set of numbers given, that is 6 by 7, half, 0, 1 by 0 and 100 by 0. So I need to pick rational number out of these numbers. Now it's very simple, okay? Let's see that what rational numbers are, okay? Let's remind ourselves again. So rational numbers are of the form P by Q. Now because rational numbers are of the form P by Q, where P and Q are both what? Okay, where P and Q are both what? P and Q are integers. So that means P and Q both belong to a set of what? Integers, correct? Where Q cannot be equal to 0. So these are the conditions which should satisfy whenever I'm talking about a rational number, and this is exactly what we have discussed till now, right? So that means whenever I am seeing a number, so we like first let's start from 6 by 7. So in 6 by 7, they are of the form P by Q, so they are satisfying this condition. Now both P and Q, that is 6 and 7, both of them belong to the set of integers, so they satisfy this condition as well. And Q is not equal to 0, that means in this case 7 is not equal to 0, that means 6 by 7 is going to be a rational number. So this is going to be your rational number. Whereas when I talk about the second number, that is 1 by 2, this is also going to be a rational number because it's of the form P by Q, where Q is not equal to 0 and P and Q both are what? Belong to a set of integers. So this is also going to be your rational number. Now when I talk about 0, now there is this ambiguity among people that whether 0 is a rational number or not. But mind it, 0 is a rational number. Why? Because 0 can be written as what? 0 by 1. Correct? Where both 0 and 1 are what? They belong to a set of integers. Correct? And where Q, in this case, where Q is equal to 1 in this case is not equal to 0. So that means 0 is also a rational number. So what did we understand from this? We understand that P can be equal to 0 in a rational number, but Q can never be equal to 0. And this is exactly why our last two numbers, that is 1 by 0 and 100 by 0, cannot be a rational number. Why? Because in this case, your Q equal to 0. And when Q is equal to 0, then that means the value of 1 by 0 or 100 by 0 is not defined, which means we cannot exactly point out as to what these numbers suggest. Therefore, these numbers are not rational numbers. They obviously are like a group of numbers, but we cannot define right now that what exactly they are, and they are surely not the part of the set of rational numbers. So therefore, if I need to pick the numbers that are rational numbers from this set, it will be 6 by 7, 1 by 2 and 0. So these three numbers are rational numbers, and the last two numbers which are given, they are not rational numbers. I hope you people have understood this. Now let's move on to the next topic. Now we need to understand that what are properties of rational numbers. Okay, now there are a lot of properties of rational numbers which we are going to study. For example, the closure property, the associative property, the distributive property, commutative property, and other properties as well. So without further ado, let's begin with the first property. Alright, so let's see what the closure property says. Now for any two rational numbers, say a and b, the result of addition, subtraction, multiplication operations give what? A rational number. So basically what it's saying is that whenever I am going to like add any two rational numbers, then the result is also going to be a rational number, and similar is the case with your subtraction and your multiplication. So let me just say it out loud again, that for any two rational numbers, let's suppose they are a and b, the result of addition, subtraction and multiplication operations give what? A rational number. Now since the sum of two numbers end up being what? A rational number, we can say that the closure property applies to rational numbers in case of addition. Now let's see this all with the help of an example. Now the sum of, let's say, 2 by 3 and your 3 by 4 is going to give me what? It's going to give me 17 by 12. Now we know that 17 and 12, both of them belong to integers, and 17 by 12 is of the form p by q, where q, that is 12 in this case, is not equal to 0. That means this is a rational number. So hence for addition we have proved. Now the difference between two rational numbers result in a rational number itself. Therefore, the closure property will apply for rational numbers in case of subtraction as well. Let's see this also with the help of an example. Now, let's say I take 4 by 5 and I subtract 3 by 4 from it. So, when I do this, I will get what? So, it will be 20, 16 minus 15, that is 1 by 20. Now 1 by 20 is also a rational number. Why? Because it's of the form p by q, where q is q is not equal to 0, which is 20 in this case, and both p and q, that is 1 and 20, belong to a set of rational numbers. And like 1 and 20, both of them are what? Integers. So that means 1 by 20 is also a rational number. Hence, we have proved closure property for the case of subtraction as well. Now let's see for the case of multiplication and for addition as well. Now in case for your multiplication of two rational numbers, the result is also going to be a rational number. Therefore, we can also say in that in case of multiplication, the closure property applies to rational numbers as well. Let's take an example in this as well. That is, suppose I have two rational numbers, that is half and minus 4 by 5, and I multiply them. So my result is going to be minus 2 by 5, correct? So my result is going to be minus 2 by 5, where minus 2 and 5, both of them belong to what? Integers, and minus 2 by 5 is of the form p by q, where q, that is 5, in this case is not equal to 0. Therefore, we can say that minus 2 by 5 is nothing but a rational number. Hence, we have also proved closure property for multiplication. Now, we have seen closure property for your addition, for subtraction, and for multiplication as well. The only thing that is left is what? Your division. Now, just think that can closure property be applied to division? It's a question, right? But let's see that when we talk about division of two rational numbers, we see what? We see that when I talk about division, we can say that a is divided by 0, correct? And when I say that a is divided by 0, this can be written in form of what? A by 0. Now this is not a rational number. Why? Because here q equals to 0, which negates the property of a rational number. Therefore, we can say that closure property do not apply to what? In case of your division of your rational numbers. So I hope you people have understood that how the closure property works. Now let me just review this again. That is, closure property is going to be applied to your multiplication, to your subtraction and your addition, But in case of division, closure property does not apply. So remember this. Now there is this one question which you people might ask, that we are dividing a by 0. What if we multiply any rational number of the form p by q with 0? Will that be closure or not in case of multiplication? Now, p by q into 0 will give me what? 0. And in the previous one of the previous questions itself, we have seen that 0 is also a rational number. Therefore, we have again proved that multiplication of two rational numbers is going to give a rational number itself. So, multiplication is also suited when we talk about closure property. Now let's move forward and complete this table in which there are a set of numbers given, that is your rational numbers, integers, whole numbers and natural numbers, and we need to see that in case of addition, subtraction, multiplication and division, how many of these numbers are closed under these operations. Alright, so when I talk about rational numbers, we know that rational numbers are okay with addition, they are okay with subtraction, they are okay with multiplication, but not in case of division. This is exactly what we have studied till now, correct? So now what we need to do is we need to see that whether integers, whole numbers and natural numbers are closed under addition, subtraction, multiplication and division or not. Alright, so when I talk about integers, I can say that it's closed under what? Your addition, your subtraction, your multiplication, but not division. Why? Because if I'm going to add two integers, let's say I add 2 plus 3, my answer is going to be an integer. Similarly, if I'm subtracting 2 and 3, my answer is going to be what? Negative of 1. And similarly, in case of multiplication as well, 2 into 3 is what? 6. So it's also closed under multiplication. But when I talk about division, the same example which I took in rational numbers, I can take. That is, what if I'm dividing 2 by 0? This is going to give me an answer which is not defined. Therefore, integers under your division operation is not closed. Therefore, I have put a cross sign here. Let's see with whole numbers and with natural numbers. Now, when I talk in terms of your whole numbers, in your whole numbers as well, I can say that it's closed under your addition, your subtraction, your multiplication, but not your division. Now why? Because when I'm adding two whole numbers, let's say 1 and 5, then I will get a whole number, that is 6. When I'm subtracting, that is, let's say I'm subtracting I'm subtracting 1 with 5. I will get what? I will get minus 4. Now, is minus 4 a whole number? No, it's not. Therefore, whole numbers are not closed under your subtraction. So here, instead of tick, you have to put a cross. Next, let's see in case of multiplication. Now, when I talk multiplication, then what will be the answer? Let's say I am multiplying 6 with, let's say 2, so it will be 12. That means that whole numbers under the operation of multiplication is closed, so I'm going to put a tick here. Now let's say how the whole numbers are going to perform under the operation of division, whether it's closed or not. Okay, now just tell me one thing. What if you divide 2 by, let's say, 3? Now if you divide 2 by 3, then this is not a whole number, it's a fraction. Therefore we will say that whole numbers aren't closed under your division, so I've put a cross sign here. Now let's see what will be the case of your natural numbers. Okay, so when I talk about natural numbers, and natural numbers, when I add two numbers, that is 1 and let's say 2, I will get 3, which is a natural number. So that means it's closed under addition. In subtraction, it's actually not closed. Why? Because let's suppose I do 1 minus 2, so it's going to be negative 1, and negative 1, like I'm pretty sure you people know that this is not a natural number, it's integer. So therefore it's not closed. In case of multiplication, obviously 1 into 2 is going to give me 2, or like if I multiply any two numbers, it's going to give me a natural number. So it's closed under multiplication, but it's not closed under division. Why? Similarly, if I am dividing 2 by 3, it's going to give me a fraction, and this fraction I'm pretty sure it's not a natural number. So a natural number under the operation of division is not closed. Therefore, we have completed this table, and I hope you people have understood how you need to see whether any of your number is closed under any of your operation or not. So if you have understood this, let's move on to the next property, that is your commutative property. Alright, so let's understand what is commutative property. Now, commutative property says that for any two rational numbers a and b, if a with any operation applied with b should be equal to b any operation applied by a. So let's see what this operation is. But whenever this happens, that is the commutative property is one wherein the result of equation must remain same despite the change in order of the operands. So we will basically find out that what these operations can be. But in crux, commutative property means that the value of a particular equation or the meaning of the particular equation shouldn't change if we are changing the order of the operands. All right. Now, let's see that if we have any two rational numbers that is provided to us, and let's take a and b only. Okay. So if I'm adding a with b, I can obviously say that this will always be equal when I'm adding b with a. So that means what? That means addition is commutative for rational numbers. Let's understand this with the help of an example. So when I say that 2 by 3 is added to what? 4 by 3. This is going to be what? 6 by 3. Correct? So this is going to be 6 by 3, which is nothing but that is 2. But in the same way, if I am adding 4 by 3 plus 2 by 3, then also I can say that this is nothing but 6 by 3, which is equal to 2. Which means what? Which means that if I am adding 2 by 3 plus 4 by 3, this should be equal if I'm doing 4 by 3 plus 2 by 3. That means the order of the numbers does not matter. So therefore I can say that addition is closed under your commutative property, or I would say that commutative property is applicable to your addition. Now let's also see what happens when we do multiplication, when we do subtraction, and when we do division. Now multiplication has a similar pattern to that of addition itself, because we know that if a is multiplied by b, this will be equal to what? B multiplied by a. And if I take any example, that is, let's suppose that 2 by 3 is multiplied by 4 by 3. So this will be equal to nothing but 8 upon 9, correct? And similarly, if I am multiplying 4 by 3 into 2 by 3, then this is also going to be what? 8 by 9. That means what? That means that if I multiply 2 by 3 with 4 by 3, and on the other hand side, if I'm multiplying 4 by 3 with 2 by 3, then both of these things needs to be what? Needs to be equal. That is, they are going to give me equal answer. That is nothing but 8 by 9. Therefore, I can say that multiplication and addition, both of them are applicable when we talk in terms of your commutative property. So now we have understood that how multiplication and addition works, but let's also understand how your division and your subtraction is going to work. Alright, so let me just erase all of it. Alright, so let's see what we can do in case of our subtraction and division. So whenever I talk about subtraction, then what happens? Okay, suppose I'm saying that I subtract a from b. This may or may not be equal to b minus a. Okay, see, now the point is what? Now the point is that if I subtract any number from b, and let's say like b minus a and a minus b, the chances are that in most of the cases these won't be equal to one another. Okay, let's take an example. That is, if I take 2 by 3 and if I take 4 by 3 and I subtract both of them. All right, so this is going to be negative of 2 by 3. Whereas if I change the order of the numbers, that is, if I say 4 by 3 is what? 4 by 3 minus 2 by 3, then my answer is going to be 2 by 3. Clearly, negative of 2 by 3 and 2 by 3 are not equal to one another. Therefore, we can say that it implies what? It implies that whenever I'm doing subtraction in your commutative property, the order of operands do matter. Therefore, I would say that your subtraction is not closed under what? Commutative property. Now we have understood about your addition and your multiplication, and we have said that both of them, that is your addition and your multiplication, act in a similar way. And now we have understood that how basically the subtraction works. Now the point is that division works in the same way as subtraction. That is, for example, let's say I have to divide two numbers, okay, a by b and b by a. Now both of them can or cannot be equal. Why? Let's suppose both, like a is, let's say your a is equal to b, which is equal to 2. So let's say both of these numbers are equal. When I divide them, my answer is going to be 1 irrespective of the order of the operands. Okay, but what if my a is not equal to b? In those situations, what's going to happen? My a by b will not be equal to my b by a. For example, if I divide 2 and 3, so 2 by 3 is not equal to 3 by 2. Therefore, I can say that division is not closed under commutative property. So therefore, after understanding that how subtraction, addition, multiplication, division, all of these things work in your commutative property, we can say that whenever I talk about addition and multiplication, then both of these under your commutative property are going to act in a similar pattern and they will be closed under your commutative property. But whenever I'm talking about your division or your subtraction, then both of them are going to act in a similar pattern and they are not going to be closed under your commutative property. So this is how the commutative property works. Now, let's again, fill this table just so, we have like a fair idea how things are going. Now we know that whenever I talk about rational numbers and whenever we talk about commutative property, so addition is closed under it, subtraction is not closed, then multiplication is closed, whereas division is not closed. This is something which we have understood. Now let's do stuff for other numbers as well, that is for integers. Now whenever I talk about integers, obviously the addition needs to be the same. That is, if I'm adding 2 and minus 1, okay, irrespective of the order in which I'm adding, so 2 plus minus 1 will be equal to negative of 1 plus 2. Therefore, I would say that this like integers under your addition is closed. Alright. So now let's see about what happens when we are doing your subtraction or your multiplication or your division in case of your integers. Now whenever I am doing your subtraction in your integers, then obviously it's not going to be closed. Why? Because we know that 2 minus 3 is not equivalent to 3 minus 2. Correct? Therefore, we can say that subtraction is not closed when we talk in terms of integers for your commutative property. Whereas multiplication is going to be closed because we know that negative of 1 multiplied by 2 will be always equal to 2 multiplied by negative of 1 irrespective of the order in which I have written the numbers. Simple, right? And also division is not closed because 2 divided by negative of 1 is not equal to, actually there is this one, so it will be equal to, but let's take an example where it's not. So yeah, I would, let's say 2 and 3, okay, the easiest example possible which I have taken. So 2 by 3 will not be equivalent to what, 3 by 2. So we can say that in case of your integers, your division may or may not be closed. Now because there are cases that it's not closed, therefore we cannot say that division is entirely closed and we will just put a cross there. So now we have done for rational numbers and for integers, and we basically need to check for your whole numbers and your natural numbers. So for whole numbers, I would say that addition is closed, your subtraction is not closed, your multiplication is closed, whereas your division is not closed. Whereas in case of your natural numbers as well, your addition is closed, your subtraction is not closed, your multiplication is closed, and your division is not closed. Now, do not worry if you do not understand about whole numbers and natural numbers, that why they, act in a certain way, because I'm going to explain you right now. So don't worry. So whenever I talk about whole numbers, I would say that addition is what closed. Why? Because let's say 0 plus 5 will be equal to 5 and 5 plus 0 will be equal to 5. So therefore, I can say that for whole numbers, my addition is what closed. But subtraction cannot be. Why? Why cannot subtraction be? Because 5 minus 0 is going to be 5, but 0 minus 5 is going to be negative of 5. And I know that negative of 5 is not a whole number, it's an integer. Therefore, I have put a cross here. Simple, right? Now, whenever I talk about multiplication, so in that case also I can say that 0 multiplied by 5 is equal to what? Your 5 multiplied by 0, because the answer always needs to be 0 only, irrespective of the order in which I am doing your multiplication with your whole numbers. Therefore, it's closed and I've put a tick. Lastly, for whole numbers, we have division. Now, we know that for whole numbers, I would say that 0 by 2 cannot be equal to 2 by 0. Okay, because just 2 by 0 is going to be something which we do not know, and 0 by 2 is going to be 0. So therefore, we cannot say that for whole numbers division is closed. I would give you one more example if you people are confused with this example. I would simply say that 2 by 3, or not even 2 by 3. Let's take 4 by 2. Okay, so 4 by 2 is going to be 2, but 2 by 4 is going to be half. Now we know that 2 and half are what? They are not equivalent to one another, and half is not a whole number. So that means what? That means for your division, whole number is not closed. Correct? Correct. So now let's seek the last type of numbers, that is my natural numbers for the same. And for natural numbers as well, I've written that whether addition, subtraction, multiplication and division is closed or not. So let's take examples and understand how these things work in that. Okay, now in case of your natural numbers, when I talk about addition, so when I'm adding 1 plus 2 or 2 plus 3 or 2 plus 1, okay, so both of them are going to be equal. That means in case of your natural numbers, your addition is closed. In case of your subtraction, I would say 1 minus 2 is not equivalent to 2 minus 1, because this is going to be 1 and this is going to be negative of 1, and negative of 1 is not equal to 1, and negative of 1 is not a natural number. Therefore, for your subtraction, it's not closed. When I say multiplication, then for multiplication, both of them are going to be okay, because we know that 2 multiplied by 1 is equal to 1 multiplied by 2. As simple as that, right? So therefore, multiplication is closed and I've put a tick. For division, natural numbers is not going to be, for the same reason that, if I take 4 and 2 and 2 and 4, so 1 is going to be like 4 by 2 is going to be 2, and 2 by 4 is going to be half, and we know that this is not equivalent and half is not a natural number. Therefore, your division is not closed under your natural number. So I hope you people have understood how commutative property works in case of your rational numbers, integers, whole numbers and your natural numbers for the operations of your addition, subtraction, multiplication and division. Now before proceeding on to the next property, let's solve a few questions to see whether we have understood this entirely or not. So the first question states what? The first question states that we need to write two rational numbers whose multiplicative inverse is same as they are. Now let's see what it can be. Let's suppose we have taken a number that is 1. So the reciprocal of 1 is going to be what? 1 upon 1, which is nothing but 1. So the reciprocal of 1 is number itself, that is 1. Correct. So what is going to be the reciprocal of negative of 1? So if I'm taking negative of 1, its reciprocal is going to be what? 1 upon negative of 1, which is going to be negative of 1. Correct. So that means the reciprocal of 1 is going to be 1, and the reciprocal of negative of 1 is going to be negative of 1 only. Hence the required rational numbers are going to be what? 1 and negative of 1. That means we need to write two rational numbers whose multiplicative inverse is like the same as the numbers are. Therefore, the numbers are going to be 1 and negative of 1. Alright, so let's solve this question now. Now in this question, A is given as half and B is given as 3 by 4, and we need to verify these two equations. So we are given what? That A is half and 1 by 2, and B is nothing but 3 by 4. So initially we need to verify that A into B will be equal to B into A. Alright, so let me substitute the values. So A is nothing but half, B is nothing but 3 by 4. So when I solve this, this will be equal to what? This will be 3 upon 8. Correct. Similarly, when I solve this portion, then B is nothing but 3 by 4 and A is what? Half. So when I solve this, this is going to be 3 by 8. That is, my left hand side is 3 by 8 and my right hand side is also 3 by 8. That means left hand side equals to right hand side. Therefore, this equation is verified. Now let's verify the second one, that is A plus B will be equivalent to B plus A. Now if I solve my left hand side, so A is what, half, and B is what, 3 by 4. So when I solve this, half plus 3 by 4 will come out to be what, 5 by 4. Similarly, when I substitute B as 3 by 4 and A as half on my right hand side, this is going to be 5 by 4. That means that my left hand side and my right hand side, both of them are equal, and they are equal to 5 by 4. Therefore, this equation is also verified. So in this question, we can see that we have verified both the equation, that is A into B is equivalent to B into A, and A plus B is equivalent to what, B plus A. I hope you have understood this. Now let's go on and understand the next property. So the next property which we need to understand is the associative property. So let's see what the associative property says. Now the associative property says that for any three rational numbers, that is your A, B and C, your A having some operation with B and this whole thing combined having an operation with C will be equivalent to B having an operation with C and this combined having an operation with what, A. That means associative property is one where the result of an equation must remain same despite the change in order of your operators. So let's see how this basically functions, and let's take an example. Okay, so let's say I need to do addition in these cases. Okay, so I know that if I add 1 plus 2 plus 3, this will be equivalent to 1 plus 2 plus 3. Correct? Correct. So that means that in case of your addition, associative in rational numbers is okay. Similar will be the case with your what? Your multiplication. That means 1 into 2 into 3 will be what? 1 into 2 into 3. So this is also understandable. This means what? This means that in case of your associative property, both your addition and your multiplication are closed. That means both the operations, your addition and your multiplication, follow your associative property. Now we have seen that what happens when we add or when we multiply. But we need to see what will happen when we divide and when we subtract. So in case of your subtraction and in case of your division. So these are the two operations where we need to see what the things are going to be. Now the point is, let's take example of 1, 2 and 3 only. So let's say that 1 subtracting 2 subtracting 3 is this equivalent to 1 subtracting 2 subtracting 3. So if I solve this, this is going to be negative of 1 negative of 3, which is going to be what? Negative of 4. This is going to be 1 minus 2 minus 3 is going to be negative of 1. So this is going to be 1 minus minus is plus, 1 plus 1 2. So we can see that 2 is not equivalent to negative of 4. That means what? That means subtraction in case of your associative property is not closed. That means we cannot say that the operation of subtraction will work when we work it under the associative property. The last property which we need to check is your division property over your associative property. Okay. So when I say 1 is divided by 2 and this whole is divided by 3, will this be equivalent to 1 divided by 2 divided by 3? Let's see if it works or not. So 1 divided by 2 is going to be half, divided by 3 is going to be what? 1 by 3. That means this is nothing but this is 1 by 6. Similarly, when I do this, it will be 1 divided by what? 1 divided by 2 by 3. So this is going to be what? 1 multiplied by 3 by 2, and this is going to be nothing but 3 by 2. Now we can see that 1 by 6 is not equivalent to 3 by 2. That means what? That means in case of my division as well, I can say that associative property does not work. So at the end of all this conversation and all this discussion, we come to a conclusion that in case of my associative property of my rational numbers, your subtraction and your division are not closed under your associative property, whereas your addition and your multiplication are closed under your associative property. So let's again fill like a table, but before we fill the table, we need to answer this question. That are the two numbers a minus b minus c equivalent to a minus b minus c? Now this is something that we have proved already. Okay, so I will just tell you one thing. A minus b minus c. So this will be what? A minus b minus c. Okay. Similarly, when I say a minus b minus c, so when I'm going to open the bracket, it will be what? A minus b, minus minus will be plus, So it will be what? Plus C. So that means in the first one I'm subtracting B and C from A, whereas in the second one I'm subtracting B from what? A plus C. That means these two things cannot be equal. Let's take an example. Let's say A is 1, B is 2, C is 4. Okay. So A is 1, so 1 minus 2 minus 4, and similarly 1 plus 4 minus 2. So 1 minus 2 is going to be what? Negative of 1. Negative of 1, negative of 4 is going to be negative of 5. Whereas 1 plus 4 is going to be 5. 5 minus 2 is going to be 3. So both of them are not equal. So therefore I can say that these two numbers are not equal. So now as we have understood this, let's go and solve this table. Now for this table, let's see how the things are actually working. So I would say that in case of my all rational numbers, integers, whole numbers and natural numbers, addition is what? Addition in case of association is closed. In case of subtraction, it's not closed. Whereas in case of your multiplication, everything is closed. Whereas in case of division, nothing is closed. Alright. Now in this table only we have seen that how things actually work for my rational numbers. But we still need to verify all the things for my integers, for my whole numbers and my natural numbers. Okay. So for the property of like your associative property, I can basically say what? I can basically say that the property is basically this. Okay. So this is the property of for my associative property. Like this is the equation which we write. Now what if I actually verify this property for natural numbers and then for whole numbers and then for integers, and let's see how the things go. Okay. Now if I say for natural numbers basically it's like 1, 2, 3 and all that. Okay. So for natural numbers we have already done it. So if I'm going to just go back, we have taken the example of A, B and C. Okay. So we have seen that this does not work in case of my subtraction and in case of division. So it does not work in these cases, but in case of your multiplication and in case of your addition, it works. Therefore, like in my natural numbers, I do not have to worry. I simply have to substitute what all the answers came out. Now for whole numbers, I will take three numbers. Let's take as 0, 1 and let's take 2. Okay. So I know that 0 into 1 into 2 done in any case, like any format will be come out to be 0 because any number multiplied by 0 is going to be 0. So for multiplication, it's okay. Okay. For addition also it's okay because 0 plus 1 plus 2 in any order, the addition is going to give me the same answer. So for whole numbers is also okay. But for subtraction if I do, so that means 0 minus 1 minus 2 if I do, just do not see this, then it will be what? It will be 0 minus 1 minus 2. So this is going to be what? 0 minus 1 plus 2, that is 1. So this is going to be 1 and this is going to be what? This is going to be negative of 1, negative of 2, that is negative of 3. So the first equation, that is this portion of my equation came out to be 1, whereas this portion of my equation came out to be negative 3. And we can see that 1 and negative of 3 are not equal. Therefore, in case of subtraction of my whole numbers, associative property does not hold. Similarly, we can check for division, that is 0. Okay, I'm going to write it here, that is 0 divided by 1 divided by 2. Okay, and we can say that 0 divided by 1 divided by 2. Okay, so 0 divided by 1 divided by 2 is half. So that means this will be 0 into 2. So 0 into 2 is going to be 0. Whereas 0 divided by 1 is 0 by 1, that is 0. And 0 divided by 2 is going to be what? 0 into half. So this is also 0. So let's take one more example to see whether it stands or not. So in that example, I'm not going to take 0 because in case of 0, the answer came out to be equal. So let's take numbers which aren't equivalent to 0. Okay. So let's take one more example. Okay. So in case of my division of whole numbers, let's take again 1, 2 and let's say 3. Okay. So 1 divided by 2 divided by 3 and the other will be what? Other will be 1 divided by 2 divided by 3. So when I solve this, it will be what? It will be 1 divided by 2 by 3, and this will come out to be 3 by 2. In this case, it will be what? I think I will solve it here. So it will be half divided by 3, that is half into 1 by 3, and this comes out to be what? 1 by 6. So for first equation, my answer is 3 by 2, and for second equation, my answer is what? 1 by 6. Clearly, both of them are not equal to one another, both of them are not whole numbers. So I would basically say that division also not stands closed for my associative property. Now there is this one thing which you have noticed with the two examples that I have shown you, and that thing is what? That thing is that in case of my division, when I was doing the solving the equation with the help of 0, it actually came closed. But with one example like of the whole numbers 1, 2 and 3, the property of association for whole numbers under your division operation did not came to be like okay, it wasn't closed. This means what? This means that whenever you need to prove that any equation is true, then you need to prove that equation for all the examples which are possible across the board. Whereas whenever you need to prove that something does not follow the rule, then only one example is enough to prove it that it's not okay. Similarly, when I am going to solve it for my integers, for integers as well, I can say that it stands closed for addition and multiplication and not for subtraction and division. And if I want to take an example for integers, I can again take the example of 1, 2 and 3, and I can solve it with the help of subtraction and division. Now, I'm going to leave this exercise to you to solve and see how integers work for addition, subtraction, multiplication and division in case of your associative property. And I have faith that you people are going to do it well. So now let's move on to the last property for today, and that last property has to be your distributive property. So let's see how the property of distribution works and what is the meaning of distributive property. Now, in case of distributive property, it's basically that if we have three rational numbers given A, B and C. So we are provided with three rational numbers, that is A, B, C. Then according to the distributive property, multiplication is distributed over addition and subtraction. So basically it's saying that if I'm writing A into B plus C, so it will be AB plus A into C is going to be what? AC. So I multiplied A and B first, and then I wrote this operation that was inside it, and then multiplied B and C. Similarly, this can be done in case of subtraction as well. That is A into B minus C can be written as what? A multiplied by B. Then writing this operation, that is negative, and then that is the subtraction operation, and then multiplying A and C, so AC. So this is basically the property of distribution. It says that if I have three rational numbers, then multiplication will divide over your addition and your subtraction. I hope you have understood this as well. Now, before coming to an end of our lecture, let's solve a few questions to see whether we are, able to understand all the properties or not. So the first question says that we need to check the distributive property of three rational numbers, and those three rational numbers are 4 by 7, negative of 2 by 3 and half. So if I need to check the distributive property, it will be what? It will be 4 by 7 should be like 4 by 7 multiplied by what? Negative of 2 by 3 and subtracting half from it. Alright, so if I'm able to solve this, I can basically say that distributive property works with this. Okay, and I can also do one more thing. I have to prove that this is actually equivalent to what? This is equivalent to 4 by 7 multiplied by negative of 2 by 3 minus 4 by 7 multiplied by half. So I basically need to prove that this side of equation is equivalent to this side of equation. So let's pick up our pen and paper and solve this equation. Okay, so when I'm going to solve this, it will be what? 4 by 7 into what? Minus 2 by 3 minus half. Correct? I can take the negative common, so it will be minus 4 by 7 into 2 by 3 plus half. Now when I solve this, it will be what? 6. So 4 plus 3, which is going to be what? 7 by 6. So this is nothing but 7 by 6. So I can write that this is minus 4 by 7 into 7 by 6. So 7 and 7 subtracted, and if I subtract them from 2, my answer is going to be what? Negative of 2 by 3. So I'm just going to erase all the calculation and write the answer only here. So that means the answer of this equation is nothing but minus 2 by 3, okay? So let's write the answer. So negative of 2 by 3 is is the answer of the first equation. Now let's solve the second equation. So second equation says that 4 by 7 into this. So it's basically going to be negative of 4 to the 8 upon 7, 14 and 21 minus, okay? So this minus, if I multiply these two, so it will be what? 2 by 7, correct? So when I'm going to take like the LCM, this is going to be, we need to divide this by this, so it will be 7, then 7 into 8 minus, so if I divide this, 21 into 2, and then we need to solve this. So I can take negative of 7 common from both of them, so negative of 7 common, it will be 8 plus, now 7 is gone, so here 3 is left, 3 2s are 6 upon 21 into 7. Negative of 8 plus 6 is going to be what? 8 plus 6 is 14 upon 21. 7 2s are 14 and 7 3s are. So my answer is again what? Negative of 2 by 3. So for this equation as well, my answer is negative of 2 by 3. And for this equation, we already found out that my answer was negative of 2 by 3. Hence, I can say that for both the equation, my left hand side and my right hand side are equal. Therefore, the distributive property holds, like I would say, true in this case. I hope you people have understood this. So let's move on to the next question. Alright, so the last question of the day says what? They say is that what kind of properties does the following expression shows? So the first expression is that 2 by 3 plus 4 by 5 is equivalent to 4 by 5 plus 2 by 3. Now there are two different rational numbers in this, and we can change the order of the operands, and it's in basically holds true for the case of addition. So I would say that it's your commutative property. Correct. In the second, I would say that 1 by 3 multiplied by 2 by 3 equals to 2 by 3 multiplied by 1 by 3. So here also the order of the operands do not matter because the answer is going to be the same, and it holds true for what? Your multiplication. So it's also your commutative property. So for both the equations which were given, the property that holds true is what? Your commutative property. So we have reached the end of our discussion. Hope you found that helpful. Now you can visit EduRev and attempt the respective tests so as to check your understanding of the topic. Now, before actually leaving, we are going to like review that what all topics did we do. So we talked about the introduction of rational numbers, we talked about the uses of rational numbers, then what are whole numbers and natural numbers, integers, rational numbers, and about the properties of rational numbers, and we also did a few questions. Now, for your further practice, you can go to EduRev, and you can also buy other content of other subjects as well with EduRev Infinity at less than 80 rupees per month. Thank you. Hello learners, welcome back to EduRev. I hope you remember what all we studied in the previous lecture about rational numbers. But for starters, let's take a recap. So in the previous lecture, we studied about rational numbers. We saw that how these numbers are useful to us. Then we studied about whole numbers and natural numbers, about integers, about what are rational numbers and the properties of rational numbers. So let's move further in our journey to decode the topic rational numbers further. We'll start with the topic that is the negation of a number. Now, let's understand it in a way. For a rational number a by b plus 0 will be equal to a by b. That is, whenever 0 is added to any number, then the answer comes out as the number itself, right? That is, when 0 is added to any rational number, the result is the same rational number. So 0 will be what? 0 will be known as the additive identity for rational numbers, right? For example, if I take any number, let's say I take 5. If I add 0 to 5, then my answer is also going to be the same number which I originally took, that as 5. And in place of 5, I can take any number. 1, -1, 100, -73, -64, etc. Okay, so there can be any number in this place, and whenever I'm going to add 0 to that number, my answer will be the number itself. So therefore 0 is termed as what? 0 is termed as the additive identity of rational numbers. This means what? This means that whenever any number is added to 0, we will get the same number back. So it's what? The additive identity for rational numbers. Now if a by b plus minus a by b is added, we will get what? We will get 0. How? A by b plus negative of a by b is basically what? A by b minus a by b. And obviously this will be what? This will be equal to 0. For example, if I take 5 and add it to negative of 5, obviously the summation of these two numbers will be what? 0. Therefore, 5 and negative of 5 are termed as what? Additive inverse of each other. This means what? This means that whenever the negative of any number is added to that number, we will get what? 0. So that number is known as what? The additive inverse of that. So in this slide, we actually learned about two things. First is, alright, so the first topic which we learned was that what is the additive identity of rational numbers. That is that whenever 0 is added to any number, we will get that number back again. The second concept which we understood was the additive inverse. That means whenever any number is added to its negative, then we will get what? 0. And that number is known as what? Additive inverse or negative of a rational number. I hope you have understood this. Now let's move forward to another concept, which is reciprocal of a number. So let's see what is reciprocal of a number. So for any rational number, let's say a by b, a by b into 1 is nothing but a by b, right? That means whenever I'm going to multiply 1 with any rational number, I will get the number itself. Therefore, 1 will be termed as what? 1 will be termed as the multiplicative identity for rational numbers. Now, in the previous slide, we studied about the additive identity. That means whenever any number is going to add to 0, then we will get the number itself. Similar to additive identity, we have multiplicative identity. That means if any number is multiplied by 1, we will get number itself. Now, in the previous slide, we studied about additive inverse. So that means we might also have a multiplicative inverse, and we have it. So whenever a number a by b is multiplied by any number c by d such that we get 1 as a result, then we say that c by d is nothing but multiplicative inverse of a by b. Now, if you remember, then in inverse, additive inverse of your number, we were basically saying that if 5 is added to its negative, then we will get 0. So that means in multiplicative inverse, you should multiply something to a number so that we will get 1. Okay. So suppose my number was x. So what should be y so that I will get 1? So y has to be nothing, or I can say 1 by x. So that means when x is multiplied by 1 by x, I will get what? 1. And 1 by x will be termed as what? Multiplicative inverse of x. So I hope you have now understood that what is additive identity and multiplicative identity, and what is additive inverse and your multiplicative inverse. So now let's move on to the fun part. Now let's see how we can represent rational numbers on number line. Now we all know that how we can represent integers, whole numbers and natural numbers on number line, right? We know that what are natural numbers? They are numbers 1, 2, 3 and all that, right? So we can simply mark these numbers and we can represent natural numbers on number line. Then if I add 0, we can represent whole numbers, and finally adding the negative numbers will give me integers. Alright, now we basically need to see how we can represent rational numbers on number line. Alright, now we have seen how we can actually represent your natural numbers, whole numbers and integers on number line. Now it's time we understand how we can actually represent rational numbers on your number line. So to represent rational numbers on number line, there are a few steps which we need to follow. So let's see step by step how we can do that. Step 1 is, firstly, we need to divide the distance between two consecutive integers into n parts. Now, what is the meaning of this step? We will understand it with the help of an example. So let's suppose that I need to represent 2 by 3 on number line. Okay. So basically what I'm going to do, I'll just draw like 0, 1 and 2 and then 3 and so on. Alright. So now the point is that I am now going to divide any space between two consecutive numbers into three parts. Now I have to represent 2 by 3. Okay. So I am going to divide the space between any two consecutive integers in how many parts? Three parts. Okay. So let me just change the color of the pen. So let's suppose the space between 0 to 1 I divided in three parts. So let's say I've divided this in three parts. Also the space between 1 and 2 I have divided in three parts. Similarly, the space between 2 and 3 I have divided in three parts, and so on. I'm going to do it. Okay. Now the step 2 is going to tell me that I need to label the rational number till the range includes the numbers you need to mark. For example, I've divided this. Okay. So I'm going to label it what? Now this is 0. So this has to be 1 by 3. Okay. This has to be 2 by 3. Now this has to be 3 by 3. But we know 3 by 3 is nothing but 1. So I've written 1. Then this will be what? 4 by 3. Similarly, this will be 5 by 3. Now next is going to be 6 by 3. But we know that 6 by 3 is going to be nothing but 2. So we have written 2 here. Okay. So similarly, I'm going to name all the points which I have made. Now I want to find out 2 by 3, so I'll see where 2 by 3 is and I will mark that rational number. So this is the process of how you can actually represent a rational number on a number line. I'm going to explain it to all of you once again so that you people, the concept is logged in your mind. So let's take the same example. So let's say that you have to do what? You have to represent 2 by 3 on number line. So basically what you need to do, you have to divide the space between any two consecutive number into three parts. Okay. So your denominator is 3. So you have to divide the space between any two consecutive numbers into how many parts? Into three parts. That is, if I'm drawing a number line here, if this is 0, this is 1 and this is 2. So you basically have to divide the space within three parts. So let's divide. So let's say that this and this is the divisions which I have created. Similarly, this and this is the division I have created, and so on. So this number is going to be what? 1 by 3. This is 0, this is 1 by 3. This is going to be 2 by 3. Now this is going to be 3 by 3, which is 1. So I have just written 1 instead of 3 by 3. You can also write 3 by 3 if you like so. Then this number is going to be 4 by 3. Then this number is going to be 5 by 3. Now, in place of 2, I can also write 6 by 3 because we know that 6 by 3 is nothing but 2. So I'm going to name all these points, and after naming all these points, I just have to mark the number which I want. Now I want 2 by 3, so I'm just going to mark the number 2 by 3. That is the number that is required by me. So this is how you represent number on number line. I hope that you have understood this now. Now let me ask you something. Can there be rational numbers between any two rational numbers? So suppose there is one rational number and there is second rational number. Can there be rational numbers between any two rational numbers? The answer is yes. There can be rational numbers between any two rational numbers. The only thing is that we should be able to formulate methods in order to find out the rational numbers between any two rational numbers. Now, there are rational numbers between any two rational numbers, but the number of rational numbers between any two given rational number isn't defined, unlike that of whole numbers or natural numbers. For example, when I say that how many numbers, like I would say integers or whole numbers or natural numbers between, let's say, 2 and 10, then all of you will say what? There is 3, there is 4, there is 5, there is 6, there is 7, 8 and 9. So that means there is a definite set of numbers that lie between any two numbers, whether they are integers, whether they are whole numbers, whether they are natural numbers, etc. Okay. So whether they are natural numbers. But when I talk about rational numbers, so there is no definite set of numbers which can lie between two rational numbers. So in order to find rational numbers, we need to apply certain techniques which are going to help us to find as many possible rational numbers as we want, or as the question asks us, between any two given rational numbers. So let's see how we can do this method by method. So the point is, method 1 says what? Method 1 says that we have to find the equivalent fraction of the given rational number and write the rational number which comes in between these numbers, and these numbers are the required rational number. Now the point is that this method might seem a little bit like off, but it's actually very simple. So I'm not going to explain you this method right now here, but I'm going to explain you this method on the next slide with the help of an example. So there is this question which is displayed on your screen, and this question is asking that we need to find the rational numbers between 1 by 10 and 2 by 10. That is what? That is that you need to find maybe like 2, 3, 5 rational numbers between your two rational numbers 1 by 10 and 2 by 10. Now to find the rational numbers between two rational numbers, what you need to do? As we can see that there are no visible rational numbers between these two rational numbers. So we need to write the equivalent fractions of the number which are given to us. Alright. So what I'm going to do, let's say that I multiply the numerator and denominator of both these numbers by 2. Okay. So if I am having 1 by 10 and I'm having 2 by 10. Okay. So let's just multiply 10 with numerator and with denominator. So when I'm multiplying 10 with numerator and multiply 10 with denominator, similarly 10 with numerator and 10 with denominator. So after doing so, my answer will come out to be what? 10 upon 100, and in this case my answer will come out to be 20 upon 100. Now there is this one thing which you can notice, and that one thing is that this number is 10 and this is 20. So your denominator is what? Same, but your numerator is different. So can, like with common sense, you can say that 11 by 100 will be between them, 12 by 100 will be between them, 13 by 100 will be between them, and so on till 19 by 100 will be between them. So all these rational numbers are the rational numbers which are going to be between these two pair of numbers, right? You can actually find out more rational numbers as well. Like for example, if you want to find out more rational numbers, what you can do, you have 10 by 100, you can take 11 by 100 as a rational number, and similarly you can multiply 10 with numerator and denominator, and again by applying your common sense you can find the rational numbers between these rational numbers. Now this is one method of doing it. Okay, this is one way of doing it, that you are actually multiplying 10 with both numerator and denominator of both the numbers. There is this one more method which you can do. It's not exactly one more method, but one more way in which you can do. What you can do is you can keep 1 by 10 as it is. Okay, you can keep 1 by 10 as it is, but you can multiply 10 with numerator and denominator of the second number. So the two numbers which we get are going to be what? It's going to be 1 by 10, and the second number is going to be what? 20 upon 100. Okay, so the second number is going to be 20 upon 100 and the first number is going to be 1 by 10. So how many numbers are between these two? So you can simply write what? 2 by 100, alright, 3 by 100, 4 by 100, and so on, 19 by 100 till 19 by 100. Okay, so these are the numbers which you can write between these two numbers. So this is how you can actually find rational numbers between any two rational numbers which are given, and this is your method 1. So I'm just going to repeat quickly that what is your method 1. In method 1, simply what you do is you multiply your either your first number or your second number or both of your number with a number which is going to create a visible gap between the two numbers which are given to you, so that you can utilize that visible gap in order to find out the rational numbers which you want to find out. Alright, so this is method 1, that is your technique 1. Now let's understand that what is technique 2. So when I talk about technique 2, they are basically saying that we need to find the mean, that is average of the two given rational numbers, and the mean is the required rational number. So basically what they are saying is, in the first case we multiplied the first number and the second number's numerator and denominator with a number, and then we found out the rational numbers between two pair of numbers. In the second method, we are basically saying that we have two rational numbers and we want to find out the rational number. So in that case, what we are going to do, we are going to find the average of those two rational numbers, and because the average, that is the mean value, needs to be between those two rational numbers itself, so therefore the required answer which we have is going to be what? The rational number itself which we require. Now let's understand this as well with the help of a question. Now the question says that we need to find the rational number between 1 by 10 and 2 by 10. So what I'm going to do is I'm going to take the mean of these two numbers. So the mean is going to be that I need to add these two numbers, 1 by 10 and 2 by 10. After adding these two numbers, I have to divide the number by 2. So it's simply going to be what? It's simply going to be 3 by 10 upon 2. Okay, so when I'm going to like take the reciprocal of it, it will be 3 by 10 into half. So my answer is going to be what? The answer is going to be 3 by 20. So that means 3 by 20 is a number that is between 1 by 10 and 2 by 10. So basically, what is the meaning of this? The meaning of this is that I wanted to find out a rational number between 1 by 10 and 2 by 10. And because I wanted to find out a rational number between these two given numbers, and I had the concept of averages, and I know that average of two given numbers is going to be between those two particular numbers. So I found out the average of 1 by 10 and 2 by 10 by adding them and then subtracting them by 2, and I found out the answer to be 3 by 20. So 3 by 20 is basically a rational number that is going to be between 1 by 10 and between 2 by 10. Similarly, if you want to find out more rational numbers, what you can do it, you can take the average of 1 by 10 and 3 by 20. So there will be a number between these, and then you can also take an average between 3 by 20 and 2 by 10, and there will be a number in between these. So the answer will be what? 1 by 10 average, 3 by 20 average, 2 by 10. Now if you want to further find out the rational numbers, you can again take the average of these two numbers, then these two numbers, then these two numbers, and then these two numbers, and so on. This process will go on till the time you basically get all the required number of rational numbers you want. And so yeah, these are basically the two methods which you can apply in order to find out the rational numbers between any two pair of rational numbers. So before departing, let's do one more question to understand the concept clearly. So basically in this question they are asking that we need to find the rational number between half and 1 by 3. Now we know that there are two methods like in order to which we can actually find the rational numbers. But let's do one thing. Let's just take the average method and let's find a rational number between 1 by 2 and 1 by 3, because there is like only one rational number which we want to give between 1 by 2 and 1 by 3. So let's find out their average and let's just solve this question. So basically for the average I need to add these two numbers, that is half plus 1 by 3 divided by 2. So when I'm going to do this, so it will be what? It will be 3 plus 2 upon 6 into half. So it's going to be 5 by 12. That means 5 by 12 is a rational number that is between half and 1 by 3. So if I need to write them in order, then my answer is going to be what? My answer is going to be half, then it's going to be 5 by 12, and finally it's going to be 1 by 3. And similarly, in the way I have explained you earlier, if I want to find out more rational numbers, what I can simply do is I can find the average of this, then the average of this. So it will be half of x, half x, then 5 by 12, then y, then 1 by 3, and so on. This process will go on. So I hope you have understood this question and all the concepts which we have discussed in this lecture. Now let's quickly take a recap of all the things which we have studied so far so that they are, embedded in our brains. So firstly, we studied about the negation of a number, that what is negative of a number. Then we studied that what is reciprocal of a number. We studied about, like x and half. We studied about your additive inverse, your multiplicative inverse, your additive identity, your multiplicative identity. And then we saw that how we can actually represent rational numbers on number line. We saw that we were able to represent natural numbers and whole numbers and integers on number line. So what is going to be the technique of representation of rational numbers on number line? And finally, we saw that how we can figure out rational numbers between two rational numbers. So we have reached the end of our discussion. Hope you found this helpful. Now you can visit EduRev and attempt the respective test for your understanding of the topic. You can also find more amazing content on other subjects like your social studies and science and whatnot. So what are you waiting for? Go and check it out. You can also buy all the logged content by EduRev Infinity at less than 80 rupees per month. Thank you.